Hello, everybody. This lesson is for our June 22nd class, our 7th class, and it is for Unit 3B, and it is the end of Unit 3, and you will have your Unit 3 test on Wednesday. So on Wednesday, we will meet live at 6 o'clock on Collaborate, and we will review, and then starting at 7:15, you will have your test. All right, so make sure you come live on Wednesday night at 6 o'clock. But this lesson is over rates, ratios, and proportions. So here we go. So a ratio, it says write a ratio to compare two different quantities. Units are important and are always included if they are present to begin with. The examples below demonstrate the different notations you may see when writing ratios. So ratios are very similar in fractions in ways that first of all, a ratio can look just like a fraction. Another way is that you can simplify ratios just like you do fractions. There's actually 3 different ways to write ratios, but all 3 ways are pronounced the same. So in example 1, they use the word to. And that's the first way to write a ratio. Oh, I forgot to plug up my little pad here. I'm sorry, 1 second. There we go. Now I have my pad plugged up. So in the first example, it says write 8 feet to 16 feet as a ratio in simplest form. So one way to represent ratios is the word to, which is what they're using here in the first example. Another way to show ratios is with a colon, like example 2, write 6 to 18 as a ratio in simplest form. So even though you don't see the word to, you would still say it when you know it's a ratio. And then finally, if you say something like, for every 5 guys in this class, there are 6 girls. So the ratio would be 5 to 6. And you could write a ratio that looks like a fraction, and you would say it the same way you would say example 1. So it says write 8 feet to 16 feet as a ratio in simplest form. So if I wrote 8 to 16 that looks like a fraction, then you would realize both of these numbers are divisible by 8, and you would simplify a fraction to 1 to 2, or 1/2. So I'm going to simplify this ratio in the same way. So the ratio would be 1 foot to 2 feet. That's the ratio. So it's the same as this, except it's simplified. Example 2, write 6 to 18 as a ratio in simplest form. Now in this ratio, they don't give the units, so we can't assume what we have 6 of and what we have 18 of. But in the first one, they did include the units, so it says that you want to make sure that you do write the units when they're presented. So what can we divide 6 and 18 by? Well, they're both divisible by 6. So 6 divided by 6 is 1. 18 divided by 6 is 3. So 6 to 18 is equivalent to 1 to 3. 1 to 3, not the number 2. All right. Now let's look at the second page or second slide. It says if the quantities you are comparing have different units, then your ratio is known as a rate. Units are especially important here and should absolutely be included. So it says to write 12 miles in 10 hours as a ratio in simplest form. So if you remember the first 2 examples, well, the second example, we weren't given our units, but the first one we were given our units, which were feet. So since we're using the same unit, this is a ratio. However, in these examples, we have 2 different units or 2 different things. And so when you have 2 different types of units, you have a rate, not a ratio. So if I go 12 miles in 10 hours, that's called a rate because we have 2 different things. So can I divide 12 and 10 by the same number? Yes, I can divide them both by 2. So I have 6 miles to 5, excuse me, 10 divided by 2 is 5. If I traveled 12 miles in 10 hours, that means I could go 6 miles in 5 hours. Example 4, in a small bag of mixed nuts, 15 were peanuts, 20 were almonds, and 5 were Brazil nuts. Write a ratio of peanuts to almonds in simplest form. So peanuts, how many peanuts do I have? 15. 2, how many almonds do I have? I have 20. And then it says simplest form, so I'm going to divide both of these by 5. So my rate would be, I have 3 peanuts to 4 almonds in simplest form. All right. So I have some for you guys to try. So you're going to simplify these ratios. It says use the information to write in simplest form. Indicate if the ratio is also a rate. So if you have 2 different things like geese and ducks, you have a rate, okay? All right, so here's 2. You're gonna do 5, A and B. And we have lesson 7, write those in simplest form. And I think that's all. So just this one slide. So if you want to go ahead and pause the video, try these, and then come back and see if you got the right answers. All right, so 5A is a ratio. So our simplified ratio is 1 foot to 2 feet. Letter B, I can divide both of these by 3. So I have 4 geese to 5 ducks. Write each ratio in simplest form. Letter A, can I do anything to 3 to 7? Nope. Letter B, I'm going to divide both of those by 4, so I have 1 to 3. Letter C, 12 inches to 24 inches is 1 to 2, 1 inch to 2 inches. And then can I divide 14 and 42 by the same number? I can divide them both by 2, but I could also divide them both by 7, which means if they're divisible by 2 and 7, that means they're divisible by 14. So 14 divided by 14 is 1. And 42, I think that's 3, right? 42 divided by 14 is 3. So 1 to 3. So if you got 7 to 6, wait, hold on. If you got 7 to 21, you still have to divide by 3. And then letter E, I can divide these both by 2. I think that's all, right? So I would get 8 to 21. Yep, in that simplest form. So hopefully you got all those right. All right, moving on, unit rates. A unit rate is a special kind of rate in which the denominator of the ratio is equal to 1. This kind of rate allows for easier comparison of different rates as seen in the example below. As with rates, units are essential and must be included. So it says, which is faster, 12 miles in 10 hours or 10 miles in 8 hours? So we're going to use unit rates to compare. So basically, if we can go 12 miles in 10 hours, we want to know how many miles we can go in 1 hour. Well, the only way to get this denominator to 1 is divide both of these by 10. Correct? 10 divided by 10 is 1. So 12 divided by 10 is 1.2. 1.2 to 1. Well, 1.2 what? So basically, it's telling us we can go 1.2 miles per hour. In other words, if you just take your original ratio and divide the top number by the bottom number, it's going to go straight to your unit. How many in 1 hour? How many miles in 1 hour? So it wants to know which is the fastest. So the first ratio tells us that we can go 1.2 miles per hour. What about 10 to 8? I'm going to divide 10 by 8. 10 divided by 8, and I would get 1.25. So 1.25 what? 1.25 miles per hour. So which rate is faster? 1.2 miles an hour or 1.25 miles an hour? So the answer is this one. This is the faster rate. And it's hard to tell that unless you find out what the unit rate is. So remember, unit rate is how much for one. How many miles per 1 hour, how many dollars per item, how many, anything per one. All right, so look at number 7, example 7. Determine which bag of Cheetos is the better buy. What does that mean, the better buy? It means which is the cheapest item, right? If you go to the grocery store, you want to get the best buy, which means you want to pay less for the same amount or the same type of food. So if you are going to buy cereals, they have the very small box, the medium box, the large box, and now they have the super family size boxes. So if you're going to find the unit rate, you would want to divide the price by how many ounces are in a box, and you want to buy the one that's the cheapest without, you know, of course, wasting food isn't saving money. So anytime you have money, almost always you do unit rate. It's always the first number divided by second number, almost always. The exception is if they have money, even if the money comes last, you always divide the money by the quantity. So I want to know if I can buy a bag for $4.99 and it's got 20.5 ounces. I want to know how much it costs per ounce. So I'm going to divide the money by the ounces. I'm going to use my calculator. And I found out that we're going to spend, I'm going to round it to 24 cents. It's 0.243, but it's 24 cents per ounce. Okay? 24 cents per ounce. What about bag B? What if I divided $4.29 by 12.5? That tells me that I am spending 34 cents per ounce. So the question is, which one's the better buy? The answer is bag A. Even though bag A costs more at the cash register, it's actually a better buy than bag B because I'm spending less per ounce. And if you go to the grocery store, if you go to Kroger or Publix and you look at the little tag on the shelf, 95% of the time it tells you the unit rate. 95% of the time. Just look at the little tag and it'll say some, you know, use some sort of abbreviation. So if you really look at it, you can figure out which one is the unit rate. And I always look at that price when I'm going to buy something because I want to buy the most for my money. All right, write each of the following as a unit rate. So if there are 5,280 feet in a mile, well, that is, oh, these are already in unit rates. I was about to say that's already in unit rates, but it wants you to write it as a unit rate. Write each of the following as a unit rate. I don't understand. I don't know. I guess feet as a unit rate for one. Oh, I think I understand. So we're going to write it as, let me erase this. Whoops. All right. So if I want to write it as a rate, similarly to how I wrote these answers, you see how I did the little slash. So if I can go 5,280 feet in 1 mile, I'm going to go 5,280. I don't understand this. Feet in a mile. Feet per mile. 5,280 feet per mile. That's the unit rate. All right, if there are 60 seconds per each minute, then we would write it 60 seconds per minute. If gasoline costs $3.49 per a gallon, that means per gallon. So anyway, those are written as unit rates. All right, moving on. Oh, it wants you to try. So remember earlier when I said almost always you divide the first number by the second number, and I said except when it's money. So keep that in mind when you're finding out how many pills you're spending, how much you're spending per pill. Okay, so these are written backwards. Options 1 and 2 are both written in opposite order because you always, always, always divide the money by the quantity. All right, so let's see how many. I have 3 slides for you to do. So you're going to do number 9, and you're going to do the next 2 slides. And then come back and let's check our answers together. Okay, so pause it, please. All right, so number 9, option 1, if I buy 360 pills for $15.45, I want to know how much each pill would cost. So I'm going to divide the money, 15.45, by 360 pills. So that means I am spending 0.042. So that means I am spending 4 cents per pill. Option 2, I am 300 pills for $12.98. $12.98 divided by 300. That cost me 4 cents. Oh, I should have gone farther because they both round to be 4 cents. So that means I need to know what's the next number or 2. 0.0433 for option 2, and option 1 would have been, let me erase this. This one is, what'd you guys get? I got 0.043 or 29 per pill. So which one is a better buy? 0.042 or 0.043? Barely, but this one is the better buy. So once again, it costs more at the register, but you're getting a tiny bit more pills per, spending less per pill, okay? And almost always that's the case. The bigger you buy, the bigger quantity you buy, the cheaper you'll get it. That's all. That's almost always the case. That's why people love to go to Sam's. You get the most for your money. Write each rate in simplest form. So 30 and 4, I can divide both of those by 2. So I have 15 miles per 2 hours, or in 2 hours. I shouldn't use per because that's not unit rate. So let me get rid of that. They use the word in, so I'll just use a colon, it's fine. All right, number 2, I'm going to divide both of these by 4. So this would be 6 inches. Now that's for 1 foot, so I'm going to put per foot. That is actually unit rate as well. So 12 boys to 18 girls. Those are both divisible by 6. So it'd be 2 boys per, or 2, 3 girls. 2 boys to 3 girls. 18 and 32 are both divisible by, is it just 2, I guess? Yep, 18 divided by 2 is 9 cars to, what was 30, half of 32 is 16. 2 cars to 16 bicycles. And then 15 men to 35 women. Those are both divisible by 5. So 3 men to 7 women. 3 men to 7 women. All right, one more slide. Let's see. Write the unit rate in each of the following round to 2 decimal places. So this is what we want to find out. How fast can we go per hour? Letter B, how many inches per foot? Letter C, how much per gallon? So we would divide miles per hour. So I'm going to divide 150 divided by 3. So that would be 50 miles per hour. I could write it like that, or the slash. 24 inches to 2 feet would be 12 inches per foot, of course. And then we're going to divide our money by our quantity. So I get $4, and round it correctly, 56 cents per gallon. All right. Oh, there's 2 more. Letter D. $1.45 divided by 6 would be about 24 cents per ounce. And 74 divided by 12, we're going to round to 2 decimal places. So we would write 6.17 pounds per square inch. I think we're done now, really. All right, now we're moving on to proportion. So if you have two ratios, like 12 miles for every, or 10 hours, and then another ratio 6 miles to 5 hours, when those two ratios are equivalent, and you know they are because they've even put an equal sign between them, that means those ratios are proportional, or in other words, they form a proportion. So 6 miles in 10 hours is the same as saying 6 miles in 5 hours. They are equivalent. And so that means the rates are proportional because they're equal. All right, so it says in example 3, we were given the rate 12 miles in 10 hours, which we simplified to 6 miles in 5 hours. Let's see how we might write that as a formal mathematical statement of equality. And they wrote it that way. It says the statement above is called a proportion because it sets two rates or ratios equal to each other. Because the above rates are equivalent, the equality statement is true. Suppose, however, that the following problem was posed. If George walked 6 miles in 5 hours, how far would he walk in 10 hours? So since we know that George's relationship to the first amount of information is going to be equal to the second part of the situation, that means that those two rates are going to be proportional. So we can set up a proportion to figure out the answer. We will use the concept of variable from lesson 6 to set up the following proportion. So the thing about proportions is that you want like things together. So for example, here we're using miles an hour. So on the top of both proportions, or both ratios, we have miles, and on the bottom we have hours. If you used miles first and hours second on the first ratio and you flipped it and did hours over miles, that would not be proportional. So you have to make sure that like things stay together, either on the top together or on the bottom together. So if you set up this proportion, then we could solve this. We could figure out what X would represent. So here we got the same information. We just dropped the words, we just used the numbers, and it says the distance George walks in 10 hours is our unknown value and is represented by the variable X. Technically, my words are being hid. I can't really read that. So we already know that the solution is already 12. We already know that. But how would we determine that? First, because of ratios of units are the same, miles over hours, we can simplify our statement this way. We're going to use cross products. So we're going to multiply from bottom to top or top to bottom. It doesn't matter the situation, but let's be consistent. We'll do bottom to top. So we're going to multiply 10 times 6, and we're going to get 60. And then we're going to multiply 5 times x, and we get 5x. And now we want to solve for x. So whatever's being multiplied by x, you're going to divide both sides of the equation by that number. So 5 divided by 5 is 1, and 1 times x is x. So 60 divided by 5 is 12. So that tells us that our variable is 12. So 12 to 10 is the same as 6 to 5, which that makes sense because 5 times 2 is 10 and 6 times 2 is 12. But sometimes they're not that simple that you can't do them in your head. So we have to know how to solve it. We're going to solve it by using cross products. The final answer to our original question, if George walked 6 miles in 5 hours, how far would he walk in 10 hours, is that George could walk 12 miles in 10 hours. We solved this problem using proportional reasoning, one of the most used problem-solving techniques in mathematics. Yes, if you can make a proportion for almost any situation, then you can probably figure out the answer. So it says, example 10, use the cross product method to determine the value for t in each of the following proportion problems. Round any decimals to the hundredths place. So we're going to use cross product. So 4 times t is 4t. 3 times 40 is 120. We're going to divide both sides by 4. Whatever's being multiplied by your variable, that's what you divide by. So t is equal to 30, which makes sense because doesn't 4 times 10 equal, 4 times 10 is 40. So if we multiply 3 by 10 also, that would be 30, which makes sense. All right, what about this one? 3 times 2 is 6. 5 times t is 5t. So then we divide both sides by 5. Oh, whoopsie. Sorry, not 6, 5. And so we're going to divide in our calculator because it's not a whole number. 6 divided by 5 is 1.2. 1.2. So t is equal to 1.2. All right, example 11. Use the cross product method to determine the value for x in each of the following proportion problems. Round any decimals to the hundredths place. So we're going to cross multiply. 6 times x is 6x. And 12 times 18 is, 12 times 18 is, I'm doing it again, 12 times 18 is 216. So then we're going to divide both sides by 6. 216 divided by 6 is 36. Now, if one number will go into the number across from it an even amount of times, for example, 6 times 3 is 18, then we would be able to multiply 12 times 3 and get 36, okay? So you don't always have to do cross products if you can kind of figure out the answer in your head. However, look at letter B. What would we multiply 2.3 by to get 4.1? I don't know. So I would definitely use cross products for these problems. So I'm going to multiply 2.3 times 5.6, and I get 12.88. And 4.1 times x is 4.1x. So then we divide both sides by 4.1. And I'm going to, 4.1 divided by 4.1 is 1. So I'm going to divide 12.88 by 4.1. And my answer is 3.14. 3.14. That is the answer. All right, look at 12, example 12. These look a little different, but we're going to still use cross products. So what over 5 equals 3? So we can always, make 3 a fraction. So one way we can look at it is if we go, can we multiply 1 by a whole number to get 5? Well, yes, we multiply by 5, which means we multiply the numerator by 5 as well. So 3 times 5 is 15. So in this situation, r is equal to 15. We can figure that out by multiplying by the same digit. Look at letter B. It says that this is a fraction, but we can still multiply. What's 1/2 times r? Well, it's 1/2 r. 1/2 times r is 1/2 r equals 4 times 8 is 32. So, So this is 1/2 times r. So what are we going to divide by? We're going to divide by 1/2. 32 divided by 1/2. So I would think of it this way. 32 divided by 1/2. So how do we divide fractions? We're going to keep it, change it, flip it, and the answer is 64. 64. R equals 64. Okay, or you could always, change 1/2 to 0.5. So if you think of 1/2 as 0.5, then in your calculator, just put 32 divided by 0.5, and you're going to get 64 as well. All right, so I have some proportions for you guys to try. So you're going to do 13, you're going to do practice on this page, and practice 6. So go ahead and pause and then come back and check your answers. All right, so look at 13a. 6 times 2 is 12, so 3 times 2 is 6. We can't get from 6 to 10 by multiplying by a whole number, so we have to use cross products. So 5 times 10 is 50. 6 times p is 6p. We divide both sides by what's multiplied by the variable. So p is equal to 50 divided by 6 is 8.33. 8.33. All right, practice 4. So 2 times what is 4 was 2 times 2. So what number times 2 is 12? So that would be 6. So x is equal to 6. All right, we can't get from 3 to 5 or 5 to 3 by multiplying by a whole number. So we're going to use cross products. So 5 times 6 is 30. 3 times r is 30r. You divide by what's with the variable. So r is equal to 10. And then letter C, can we multiply 6 by a whole number to get 12? Well, of course, 6 times 2 is 12, so 10 times 2 is 20. Letter D, 3 times what is 6? Well, 3 times 2 is 6. So 1.5 times 2 is 3. And then the last one is tricky, right? So we're going to use cross product. So 2.4 times 3.8 is 9.12. So 9.12 is equal to 3.04x. We divide what's on the side with x. And x is equal to 9.12 divided by 3.04. And my answer is 3. All right, and then you had to do number 6. So I'm going to think, you know, kind of in my head, I'm thinking, well, this says a number divided by 2 is 6. What divided by 2 is 6? Well, I know the answer is 12, right? So x is 12. T is equal to 8 over 4. Well, that tells you what the variable is equal to. T is equal to 8 divided by 4, which is 2, right? And then what times 2 equals 12? Well, 6 times 2 equals 12. So I'm going to multiply 2 times 1/3. 2 times 1/3. So 2 times 1/3 is 2/3. So x is equal to 2/3. Or I could cross multiply. 12 times 1/3 is 4. And 4 divided by 6. 4 over 6 is the same as 2 over 3. All right. Hopefully y'all did great on that part. Okay. All right. So I'm going to stop right there and take a little break, and then we'll come back and finish. This is not so hard, and we're going by pretty quickly. So I'll be back.